Good afternoon and welcome to A Cleaner Space. My name is Caleb and I will be explaining the introduction and background, and my teammate Nick will then go into a demo and the technical explanation of what our web app does. So what is A Cleaner Space? It is a UI-friendly web app that uses image recognition AI to identify if your specific waste is trash, recycling, or compost, and provides a map to the closest on-campus UCSB waste bin. So our inspiration for this web app was we were both interested in environmental sustainability, and we saw that there was an increase in the amount of waste that was being generated every year. And so we wanted to create a web app that helped people identify which waste could be saved from the landfill via like recycling and compost. And so it did not need to go in the trash and could be reused. So on average, people use around 4.4 pounds of waste every day, which comes out to around 1,600 pounds of waste every single year per person. So we found that around 34% of this waste can be recycled or composted, which means that per person every year, or if someone is not recycling or composting, they could save 546 pounds of waste from going to the landfill. And our goal of our app was we wanted to educate people on what was actually recycling and compost so that we could create this save and reduce the amount of waste that was going into landfills. So on UCSB's campus, there are 79 combination waste bins, and they look like these two images here. And what our app does is it allows you to take a picture of your specific waste, and it tells you which bin your specific waste belongs in. And then there's a map that shows you where the closest combination waste bin is so that you can just go and throw it away there. Now I'm going to pass it off to Nick, and he's going to go through the demo and the more technical part of our project.
We used a React front end with a Phoenix backend for our web app. It also uses TensorFlow.js to determine the category of the input image and tells the user our predictions, so if the model makes a mistake, it should be pretty obvious to the user. So, how did we make it? First, we researched the different categories of items that would be thrown away and defined 22 different categories. Then we used a package by the GitHub user Austrolucky to download about 200 images for each category from Bing Images. Then we loaded those images into TensorFlow and trained a ResNet 50 to classify the images. Our best model ended up having a validation accuracy of 73%. Then we set up the Elixir backend to serve the model data to the front end and added routes for the counter. Finally, we set up the UI in React and added utility functions that use TensorFlow.js to classify the uploaded images. Caleb found a map of all trash cans at UCSB and used it to get the coordinates of all the triple bins, which we mapped on our site using Google Maps API. Our goal was to make this tool as easy to use as possible so people would actually use it. We encourage you now to check us out on the internet. The link is in the description and in the dev post. Just be aware it takes a bit longer to run the first time you use it because the browser caches the model data for future uses.